Hello and welcome back to Steam It with Steve. Today we're going to continue with our learning of introductory Python. And to start, we're going to learn how to do some basic math operations. Now, usually people get a little bit bored with this, but I think it's one of the most important and exciting parts in Python. Okay, so I'm going to teach you how to math basically in Python, which should be a lot of fun. So the first thing to start off, we need to learn how to do math operators in Python. Okay, now these are exactly the same as what we've done before in normal math that you've been doing since you're in grade 1. Okay, so we have addition, subtraction, multiply, divide, powers, remainder division, and then integer division. Okay, now the last two I'll talk about a little bit later, but the first 5 should look somewhat familiar. So addition, subtraction, exactly the same symbols. Okay, so just plus and minus. Multiply is a little bit trickier. So instead of using a normal X, we actually use the asterisk, which is the same as Shift 8. Or if you have a number pad, it's the top character in the right. The reason why we do that is crosses would look confusing between that and the time symbol. Okay, so particularly when we're using X's, computer scientists don't like using the time symbol. Okay, so what we do is we use the asterisk symbol just as a placeholder because it looks somewhat-ish like an X, but it's different enough that you don't get confusing when you're looking through thousands of lines of code. The next one is the divide. So there is no divide symbol on your computer. So what we do as computer scientists, we use actually the backward slash. Okay, and again, it's right there next to the shift key on the right, or on a number pad, it's next to the number lock key. Okay. The next one then is powers. So if we want to do something to the power of something, so for example, 2 to the power of 3 or 2 times 2 times 2, we actually can't write a little subscript, so we can't go 2 to the power of 2. So to do it, what we do as computer scientists is we use star star. So 2 star star 3 will give us that power. The last two I'll go into a bit more detail later, but basically it's the remainder. So if you do 7 divided by 3, you get 2 remainder 1, right? Because there's 2 times 3 is 6, and then 7 take away 6 leaves you with that 1 left over. That's the remainder. Okay, so if you do 7% 3 or 7 mod 3, that will equal 1. So we'll just give the remainder, and then when you do integer division, it's just the exact opposite. So when you do 7 divided by 3, leaves you with 2 and 1, remainder 1. When you do 7 integer division or 7 backslash 3, that will leave you with just 1. Now, just to prove that to you, we're going to actually open up idle. Okay, and we're just going to type these in just so that you can see how quick and easy it is in the computer. So if I want to do 8 plus 8, bam, there's 16. So it's a really powerful, simple, fast computer. If I do 17 take away 4, bam, it gives me 13. If I want to do, I don't know, 3 times 5, gives me that. Sometimes there's also, as computer scientists, we like putting spaces between it so that we can see a bit clearer the numbers that we're inputting. So that's what that looks like. If I then want to do divide, so let's say I do 18 divided by 9, gives me 2. Okay, and then if I want to do 2 to the power of 3, right, like what we talked about before, we do 2 star star 3, and that gives me 8. So just to prove to you, that's the same as that. Now the cool part with that, if we want to do big numbers, so I know if I want to do 2 to the power of 10, instead of having to type 2 times 2 times 2 times 2, you can do it really quickly like that. Cool. Awesome. So we're going to, and just to show you the 7 mod 3 example, 7 mod 3 leaves you with 1. And if we do 7 into division 3, would leave you with 2. Cool. So when we talked about mod, it's the remainder division. That's all we're thinking about when we're looking at this. So it finds the remainder after the division of one number by another. So for example, if we do 5 divided by 2, gives you 2.5. 5 mod 2 is just that remainder, which is 1. Okay, so hopefully that's picked up. The output of this will always go from 0 up to the number before that you divided it by. Now, this is super useful for computer scientists. One of the basic ones is when we want to look at even integers, right? So if we want to work out an even integer, if we do the mod of 2, it will always equal 0, right? And then similarly, if you want to find all the even numbers, if we do mod 2, it will always equal 1. Right? So just to prove that to you, let's go through them. So if we go to 0 mod 2, we'll start at 0. If I do 1 divided by mod 2, will give me 1. If I go 2 mod 2, see, I've done a group of 2, so then that means I have no remainder, so it will equal 0. And that's the power of mod, right? So basically, as you cycle through these, it gives you this really powerful tool that can go through and find all the even numbers, okay? Even if I want to do a really big number, as long as I ended in a 2, and I do mod 2, bam, 0. But if I do, am I gonna be able to type that number, the number after it? So 1, 2, 3, 0, 9, 8, 3, mod 2, it will give me 1. And then if I go to the next number afterwards, 0, 9, 8, 3, oh sorry, 4, mod 2, and then cycles through. Now that you don't always have to do mod 2, you can actually do any number that you want. So for example, if I do 13 mod 5, 13 divided by 5 should leave you with 2, remainder 3. So that will give me the remainder 3. If I go to the next number afterwards, I get 14. Mod 5, it gives me 4. And then if I do 15 mod 5, see, I've done a group of 5, so then it goes back to the beginning again. So then that pattern will go again. So if we use mod 5, the numbers will go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and oscillate in that pattern. Okay. Cool. So what you should have picked up is the output will always go from 0 to the number before that you're dividing it by. So for example, if we use mod 6, the only possible answers when we use this function is 0, 1, 2, 3, 4, 5. Because when we do it, it literally will cycle through those. What about integer divide? So integer divide looks exactly the same, except this time around when we do this, it will only return the whole part. So it'll only return this 2. Okay, and then that's what it would equal. So 5//2 would equal that. And then just to prove that to you, go 5//2 gives us that. So no matter how complex the number, if we do //8, right, it doesn't worry about the decimal part, it just worries about the integer part. So when we do mod, it does the right-hand side of the decimal place and finds what's involved there with the remainder. When we do integer division, it does the left-hand side. Cool. So BODMAS, what does it mean? Basically, it's used for how the computer works, right? So it will follow a pattern that the computer needs to understand and goes through and starts the most powerful thing first. So brackets are the most powerful, then operations, then divide, multiply, add, and then lastly subtract. So BODMAS doesn't mean just getting huge, okay? It actually means this pattern. So when we follow it through, brackets are the most powerful. So if you wrap something in brackets, the computer will always do that first. Then operations, so raising something to the power. It does also include all the operations that aren't the other ones, so divide, multiply, add, or subtract. Okay, then we've got divide, which includes mod and also includes integer division. They have the same power at this level. So there's actually 3 versions of divide, just to mess with your head a little. Then we have multiply, so timesing, then add, and then lastly subtract, so it's taking away. So operations, these include all the operations in math. So some people will just say powers and square roots. So you can do 2 to the power of 5. It has a more powerful thing, or roots, but it actually includes all the any other mathematical functions. So including trigonometry and logs. Okay, so these are any operations, they have that level of power. Cool. So the first example I'd like for you to have a go, and just pause the video here, is have a go and see if you can apply BODMAS to this and solve it. Great, awesome. So hopefully you've had a go. So you should have gone 7 plus 2 and then timesing it by 12 minus 8, all wrapped up in brackets. So the first thing we always do is what's inside the brackets. And this is how a computer will think. Algorithmically, it will go through and solve the brackets first. Wow, that was a bit of a tongue tie. Still waking up, sorry. So if we go through this, 7 plus 2 gives us a 9, 12 take away 8 gives us a 4. We then go through 9 times 4, right? And then that gives us our 36. The next thing that we're going to do, the computer's going to go through this and look again for the brackets. So there's the brackets there. And then it's got the power. So to do the power of 3. So we're going to go through 7 take away negative 3 gives us 10. 2 to the power of 3 gives us 8. And then we've got the 50 divided by 10 plus the 8. It would then have the choice between divide and add. So it's going to do the divide first because that's more powerful. It has precedence. So 50 divided by 10 leaves us with 5. 5 plus the 8 gives us our 13. Great. So again, just pause the video here. Have a go. Hopefully you paused it. Great. Awesome. So we're going to go through. We're going to go and look at what happens. So we've got the brackets here first, then the operations, and then a times. So we've got this power. So we're going to do the brackets first. So negative 8 plus negative 82. So that's the same as if I took negative 8. So taking 8 away from you, then taking 82, which leaves us with negative 90. Then I'm going to have that divided by 9. So 3 to the power of 2 is 9. Then just bring down the rest of it. So then I have a divide, a subtract, and a times. So we're going to do the divide and then the times together because they have the same power level almost. So negative 90 divided by 9 leaves us with negative 10. And then negative 2 times negative 6 gives us 12. Then this is the same as me taking away 10 and giving you back 12. Okay. So doing that literally leaves you with 2. So if it took $10 from you and gave you $12 back, you had $2 extra. Cool. Now the good news with this is with Python, you can get it to solve it for you, right? So you don't need to remember all of those different operations. The main thing from this is you need to remember as soon as you wrap it up in brackets, it will do that first, okay? And this is the really cool part. So in Python, we just type those things in. So I'd like for you to have a go now. Try and type these into idle and see how you go. So just pause the video there and have a go. Fantastic. So here we go. We're just going to pump these in. So we're going to go 6 plus 5 gives us 11. Then we're going to go 18 divided by 12, which gives us 1.5. 18 divided by 7, which gives us 2.5, blah, 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 blah. So it gives you the whole decimal. And just to show you, if we did 18 / 7, we just return the 2. But if we did 18 mod 7, it'd give us 4, or the remainder that would be left over. If we do 12 to the power of 2, so 12 * gives us that. And just to prove that that works, we do 12 times 12. Right. Then if we do these numbers down through here, so we're going to go 45 plus 12 times 6. So using order of operations, it would do the times first and then the add. Right. And then if we do the next one, we've got 45 bracket 5 plus 12 times the 6, which gives us the same. So you should see brackets have made it a kind of redundant here. You don't really need them because it's the order of operations would solve it anyway. However, just to prove that you can force it to do the add first, we'd wrap brackets around it and then it will solve that bit first. And then the last one, we've got 35 plus 87 times 122 to the power of 12. It would do the power first, then the times, and then the add. So if we go through this, we've got 35 plus 87 times 122 * to the power of 12. And the power with this, do you see how quickly it got a really big number? Okay, so that's what sort of exists with this. Cool. So there were the answers. So the power of Python compared to your normal calculator is because you're using a computer, it has this capacity to store really big numbers. And this is why data scientists love Python, right? So if we got 99 to the power of 1500, that's a really big number, right? That's the same as 99 times 99 times 99 times 99 times 99, and doing that 1,500 times, lots of that, okay? So to show you how cool it is, let's type that into Python. So if I go 99 * 1500, oops, too big for that. So just to prove that that works, let's go again and making it bigger. So we'll go 99 * 1500, bam. So this is a huge number, right? This is ridiculous. I'm not even going to try and attempt to read it all out, but that is what 99 to the power of 1500 looks like. Okay. Now Python has the capacity to store this number. So it's like, just to give you some perspective, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's literally what a billion is up to this part here. Okay. So this number is massive. It's ridiculous. Okay. And Python allows you to store these numbers and play around with them as well. Okay. Which is really, really cool. And that's why it's super powerful and easy to use. Cool. So it's way more powerful than a calculator. So standard scientific calculator wouldn't be able to pump out these type of numbers, but Python, it can do it. So then the next part we need to talk about is an identifier. Now, this is going to be useful when we start manipulating the data. If you've done the code combat, you should have already played around with identifiers. They're basically variables. So it's exactly the same as what a variable looks and sort of operates like in math. Okay. But when we talk about identifiers, we're actually identifying a name that we've applied to a chunk of memory. And I think of it like a bucket. So you've got a bucket of memory that we're going to try and put something into. Okay, and then what we can do is we can put things into the bucket. We can look inside the bucket to see what's there, and we can also take things outside of the bucket. Now that stuff that we put in the bucket is called data. Okay, and what happens is we're literally dumping that data into the variable, looking around, playing around with it, and that's how we can store and retrieve it. Now this is super useful in all the applications that you will ever build. Okay, it gives you a way of storing the information and then manipulating it later. So for example, if you're building a video game, you probably want to take the score and check how the player is progressing. So we would need to store that in a variable so then we can compare whether or not the game is over yet. Right? So it's used to store and retrieve the data. It's super good to make sure that we use appropriate names. Okay. So if we were making a variable to store the score and we called it, I don't know, unicorn honey, right? It's a weird name that doesn't mean anything. Whereas if we use score to store the score, do you see that's super useful and makes it easier when you're reading it? So good naming structures is super important for programming. Okay, so if you're doing the score, the lives, the X position or the Y position of the player, that's why we need to make sure we use appropriate names. Okay. So how do we assign a value to an identifier? It's super easy. You just literally use what we do in math. We go x equals 1, okay? And then the cool part in Python, you can now access that anywhere in the program. So you can now use it just as simple as that. So you go x plus 1. Now the output for this will literally spit out a 2. So if you got x is equal to 1, x plus 1, you put that in, it will go 1 plus 1, 2. So just to prove that to you, we've got a huge number there. We'll go x equals 1. And then if I go x plus 1, it spits that out. Now, just because I've gone x plus 1, that does not change the state of x. If I type in x now, it still is equal to 1. I haven't changed it yet, which we'll learn about a little bit later, okay? But the cool part is once we've got that stored, we can then access it and use it with other things. Right, so if we've got the score in our game, and let's say it's got 100 points currently, right, the score is that, and then all of a sudden we want to double our score and see what it is. If we go score times 2, it automatically spits it out for us, which is super useful, particularly when we're working with big data sets. Cool, so let's have a go yourselves. Okay, so your turn is find the output if x is equal to 5 and y is equal to 2, fill in the gaps. So x plus 5, y, fill it all in, and let's try it. So just pause the video there and have a go. So type those numbers in, fill in the blanks and see what happens. Excellent, welcome back. So we're gonna keep going. I'm gonna minimize that down again. And we're gonna have a go at these ones. So first step is gonna go x equal to 5, y is equal to 2. So I've stored those two variables in. So I can now access x and can access y. If I then want to see what x plus y is, I literally just type it. So I go x plus y. And that gives me 7. If I then go y minus x, gives me -3. If I do x backslash y, gives me 2.5. If I go x backslash y, gives me 2. So that's the integer division, which just takes the left-hand side of the decimal place. If I do x star star to the power of y, right? So x was 5 and y was 2, so that should be 25. So 5 to the power of 2. And then if I go the other way, y star star x gives me 32. If I then go x minus y divided by y, gives me 4. And then if I go x minus y divided by y, gives me 1.5. Cool. So hopefully you picked up something with that and the core skills of how to do it. The next thing that we need to talk about are the reserved words in Python. So we're going to need to store different variables with different names. These are reserved words. This means you cannot use these ever as variable names. It's as simple as that. Okay, so these are banned. You cannot use these ever in terms of Python. Right? So we just need to be mindful of that. What happens with this is they are used as the language to do specific commands in Python. So you've got your true, you've got your false, there's an if you've done the code combat, there's while, right? These cannot be used inside of your code as a variable name, okay? The good part for you is they will actually turn to orange when you try to use them in Python. Okay, so just to prove to you, down here, if I try and type true, see how automatically it changes to orange? So if I try to go true is equal to 4, can't do it. So it will not work. If I try to go del equals 6, it will say nope, not valid, because it doesn't understand it. Okay, right? But if I try to do, I know del equal 4, that's not a reserved word, so I can access it and use it. So don't use deli though, because that's a weird word. But if I want to know score equal to 12, 233, that will work. Right, so all those different words, so there's except, there's in, if, they all will change to orange if it's a reserved word. Now, sometimes they call them the holy words of Python. Okay, and I usually put these at the front of my classroom on the wall there because they're that important. Great, so there's some set rules that Python's put in place to protect the programmer and also the computer, so that you need to follow this pattern when you write your own identifiers. So it must follow this form. Identifiers must contain at least one character. So even if you just have X, all good, but it has to have a character. The first character must be alphabetic. Okay, so it must be either upper or lowercase with an underscore. So for example, A to Z, or capital letters, or A to Z in lowercase letters, or an underscore, which they use as the space symbol. Okay, which is the same as shift and the character next to the plus symbol up in the top right of your keyboard. What you should notice there is it doesn't have any numbers. So you cannot put a number on the front of a variable name. So you can't go 9 score. It just won't work. The remaining characters must be alphabetical. So it must be upper or lowercase or underscore, but now you can actually throw in some numbers. So it's exactly the same as before, but you can now throw numbers into it. What you should notice is identifiers can't have any special characters. So it can't have exclamation mark, hashes, square dollar signs, little ampersands, all those commas or anything it can't have. So it must only have letters, numbers, or underscore, and following the pattern that we just talked about. Okay, so no other characters, including space, you can't use that. And reserved words cannot be used. So those holy words that we looked at before, they're off limits. So valid identifiers will look something like that. So X is all good, total is all good, total 1. So even though it's got a number, as long as it's not the first one, all good. Total sales is all good, so it's not a space, but it's used the underscore. Using all capital letters, all good. You can do that. And then you can also put an underscore and then the name of a variable. Now, this is more for system variables, which we'll get into a bit later, but just thought you'd be mindful of that you can do that, and it does exist. Okay, these are invalid. So because there's just one character, but it's a number, that is not legal. You can't do it. 2 total, can't do it. It's got a first thing is a number. #2, so hash is illegal because that's not one of these valid characters. class is illegal because it's a reserve word, returns illegal because it's a reserve word, and then number is also illegal because it's got this little exclamation mark at the end. Cool. So have a go at that. Pause the video, see if you can work out which one's valid or invalid, and bonus points if you can work out why. Okay, so if you do get stuck, you can always type these into Python and store a little number into it. So you can just go this equals 1 and see if it works. Great, welcome back. Here we go. So let's have a go. So we're going to try and type these in. So if I go score equal 1, yep, all good, it's stored it. If I try to go hash score equals 1, and then I type in hash score, see how it's changed red? That will work out later. It basically means that it's a comment, and whenever you put a hash on the front of it, it means that the computer does understand what it means. So it just goes, no, don't need to know this, which will be useful when we'll see it later. If I go x equal to 1, that works. If I go private, now you might have thought of that might be a reserve word. It actually isn't. Okay, so that all works. If I go for score equals 3, can't do because it's got a number on the front. If I go x2 equal to 3, yep, all good. If I go 2x equal to 4, no, doesn't work. If I go sum total equals 12, nope, yep, that should work. If I go sum space total equals 23, that won't work. If I go underscore equals 3, will this work? Absolutely. So this is one of those quirky parts of Python. Okay, so even though you can do it, don't usually do it. If you do 3 of them all working together equals 4, that will actually also work as well. Again, super quirky, don't do it, but it does work and it's valid. So the first one, totally valid, all good. This one, not valid because the first character is not legal for a variable. The next one is valid. This one's valid. This one's invalid because the first character is not legal. This one's valid. This one's invalid because the first character is not legal. This one's valid. This one's invalid. This one's valid. And then this one's valid. Great. So the last bit that we're going to carry on with is a bit about how we can type our variable names. So there's there's 3 main different types of cases. So you might have heard of Camel Case or Snake Case. Okay. And we're just going to quickly talk about what they actually look like. Right? So most Python people actually like using Snake Case. I personally don't like it because it gets a little tedious. But basically the way that works is that when you write the variable name, it is all lowercase, and then you put underscores between each of the words. So if you've got something with a longer word, so for example, they've got here push something to first Q as a variable name, they've got underscores between each one. Now, I personally think that it gets a bit tedious because you've got to press shift underscore each time that you type it. And the reason why it's called Snake Case is basically each word is like a vertebrae in the back of a snake, and then the underscore is what connects the vertebrae. So it sort of should look like the bones of a snake sort of sliding across. Again, up to you. If you feel that's better for you, go for it. But personally, I like the other two. So the next one's then Pascal Case, where you basically put a capital letter at the front, and each word that you add on, you just capitalize the first letter. Okay. That was made for a programming language called Pascal. Not so bad. Then we've got Camel Case, which is the most popular one. So most people will use that. So the benefits of that compared to Pascal is you can just type it without having to press shift. So every time you write a variable, you can just write the variable name and then capitalize it. Both are quite good. So usually there's some conventions that I prefer, which I'm going to share with you after we've sort of revised this. So the variable conventions, just to go through, they've made this up so it's just consistent. So when programmers read other people's code, they understand, oh, they've used Snake Case, oh, they've used Camel Case, oh, they've used Pascal Case. And if you understand that, it makes it a whole heap easier. So Camel Case basically means any of the second words or any of the words afterwards are capitalized. Okay, so this makes it very easy to see where the boundary is. So if you just write it all in lowercase, it's super hard to distinguish where the words sort of get separated. Okay, so if we had this variable called number of college graduates, couldn't spell that one, we'd use Camel Case, right? So every time that it splits, we capitalize it. Then we've got Pascal Case. So it's identical to Camel Case, except the first letter is capitalized as well. All right, so literally instead of the N, see it's capitalized there as well. And then we've got our snake case. So down the bottom here, words are separated by an underscore. So number of college graduates literally has that underscore in between each one. Cool. Actually, I'm just going to change that. Cool. Just so for the kids when I go back to school. Cool. So we've got that. Now it's got graduates. Yay. Learn something. I am human. Sometimes my dyslexia kicks in, but it's all good. So have a go at this. Your turn. So which of the following is Camel Case, Pascal Case, Snake Case, or not used case? So we've got total score, total underscore, total score, and have a go. So just pause the video and see what you get. Great, welcome back. So the first one, if we look at it, we've got a lowercase letter at the front and then an uppercase letter there. So that's what is valid. So that is the Camel Case. The next one is valid because it's Snake Case. It's got a little underscore in between each one. The next one is also valid because it's Pascal Case. So it's got capitalized letters all the way through. Next one's not valid because it's got a space, so it's illegal. This one's not used. It is a valid, like it would work in a program, but it doesn't. It's confusing, okay? The next one's also not used, okay? Just because it's not a case. Next one's not used as well. So it's not a case, but it would run in the program. So they're legal in terms of what the computer can run, but in terms of convention for other programmers, you might confuse and scare them away. The next one is actually not used. So it's not a particular case, but it's used when we do constants. Okay, so constants are things in memory that will never change. So for example, I don't know if we're scoring a game and you had to get to 10 points, that might have a variable called final score, right? And we write that all in capital letters because we don't want that to ever change. And by putting in capital letters, it shows other programmers that is a constant. The same goes for the next one. You could say that's a constant as well, but we don't use it when we compare it to these three different cases. And the last one's not used as well, okay? Unless it's a default variable. But in terms of the three that we looked at, those are what we did. So with coding conventions that I use personally and will use in this course, I actually use Camel Case for most of the things. So for variables and functions, when we learn those, Camel Case is superior, I feel, because it's super easy. You can just type it, press shift, and then put in any extra words, okay, instead of having to press shift underscore all the time. So that's the convention that I'll be using with this course. And then you've also got Pascal Case, which we'll use for class names. So classes are basically objects, which we'll learn inside of games. So for example, player gun, the fiery sword, the metal helmet, we'll wrap them up by using Pascal Case, just to identify that they're a little different from a variable, okay? Cool. So have a go at that activity in Hour of Code. It's awesome. It will give you some basic overviews of how to use emojis and the print function inside of Python. Hopefully you picked up something from this today, learning a little bit about math. If you have any questions about identifiers or anything like that, just pop them in the comments. And don't forget to like and subscribe because it does help with our YouTube algorithm. So thanks again. See you next time on STEAM with Steve. Adios.